Welcome, folks. We're already at the end of our series of lectures for the semester and the cuts. It's been really great, I think, folks we've had. They're all were asked to speak under the rubric of perspectives of seasoned scientists. And in addition to learning about their scientific findings, we've also learned a lot about them, career trajectories, and some have offered advice to the rest of us on career development. So I think it's been really, really rewarding. It's really a pleasure to have Dr. Frank Van Manen speak with us today. Dr. Van Manen is a supervisory research wildlife biologist with USGS here in town. You probably know that he's the team leader of the interagency grizzly bear study team. Has been in that position since 2012. No doubt, he's seen a lot of positive interactions around his study species and a lot of challenging conflicts. I was tickled that his graduate work was at the University of Tennessee, where I also study. We were just talking about various of our instructors there. He stayed in the southeast for a while after that, doing research on black bears, red wolves, Florida panthers. And then in his time here, he's just done really outstanding research. That's manifest in terms of several high-quality publications. I've actually had the pleasure of working with him here in the last year or so on the project of trying to prioritize, come up with mapping efforts to prioritize biodiversity value on private lands across GWAT consideration, grizzly bears are part of that. And I just love it because Frank he's an excellent writer. And so when you send him my typical first draft that's a mess, comes back looking really good. So he's going to talk to us today about this topic of basically that science alone is not enough, grizzly bear conservation and GYE. So, provocative title, and I suspect one that we'll really enjoy hearing. Dr. Van Manen, welcome.
Thank you very much. And Sandy, when you mentioned seasoned scientist, I mentioned it to my wife this morning. She said, "Does it mean you're old?" Yes, I am. It's a pleasure to be here. I'll jump right into it, and I'll try to cover these 4 topics here today. Provide a little bit of historical context to grizzly bear conservation and the ecosystem. Focus quite a bit on the system that was set up to translate science into policy. Talk a little bit about the biology behind the recovery, and then finish up with some discussion of what are really the elements of this conservation success, and some lessons that we can learn from that. So a little bit of history. Most of you are somewhat aware of the history of Yellowstone National Park and grizzly bears and black bears there. Was not uncommon in the early days to see bears feeding in open pit garbage dumps and other human food resources that were left out. Panhandling was observed by black bears as early as 1910, I think. So there's a long history of interactions between people and bears and wildlife in general, of course, in Yellowstone National Park. To the point where bears actually started driving cars. No one told them apparently that you're not supposed to drive on the left side of the road in the United States. The story of conservation and grizzly bear conservation really starts in Yellowstone National Park in the Great Yellowstone ecosystem starts in Yellowstone National Park with the work of John and Frank Craighead. And most of you are familiar with them, of course. They were really, but I think it's underestimated how much of a pioneer they were in wildlife science. They really changed the field for us. This was the first telemetry studies being done anywhere in the world. They were the first ones to really start using satellite imagery to map habitat. So their contributions, starting in 1959, were pretty incredible. In 1963, there was a famous Leopold report. Starker Leopold and colleagues examined wildlife management in the national parks. And in those days, it was not uncommon for ungulate herds to be culled, for example. Yellowstone National Park did so. With elk herds and bison herds, and that occurred in other national parks too. And their recommendations were to move towards a more natural system of management, basically kind of a system that we know today that was relevant to bears because bears were still feeding in open pit garbage dumps in those days. In 1967, Superintendent Anderson decided to implement the recommendations from this report. And that created somewhat of a controversy because the idea was, what do we do with open pit garbage dumps? Do we close them right away or do we phase the closure out over time? There was big disagreement between the Park Service at the time and the Craighead brothers. The Park Service decided to close them pretty much abruptly over a relatively short period, but that resulted in a large number of bears dying in a short period of time. About 229 bears were killed or removed during a 5-year time period in the late 60s and early 70s. And so there was a lot of concern about this population at the time. And it received national attention. And that's why the National Academy of Sciences got involved, did a review of the status of the population. And they concluded that the population might be as low as 136 individuals. You wonder how could they determine that specific of a number? That's a great question. I don't think they could. That number is probably underestimated a little bit. There were probably more bears than that, but still the message was still valid and for sure the population was in danger of extinction. I think we have to be realistic about that. If nothing had been done, we would be seeing this population literally blinking out. So that is the reason that the population in 1975 was listed as threatened, together with all the other grizzly bears in the lower 48s under the newly established Endangered Species Act. And another recommendation from the National Academy of Sciences was, because of the controversy that ensued between the researchers at the time and the National Park Service and others, they basically said, you need to establish an independent science team where agencies coordinate efforts, but independent from their parent agencies, to really assess the status and trend of this population. And that's really when the Interagency Grizzly Bear Study Team was born in 1973. And so now it's a science consortium of 8 different federal, state, and tribal entities that work together. And I think we have a good record of scientific collaboration. Our main goals are pretty straightforward. Is to conduct research on the status, trend, and distribution of the grizzly bear population, determine food habits, habitat use, and effects of human and land management activities on grizzly bears. From that work, we typically do a lot of topical studies that address specific needs of managers, but this is kind of the 2 broader themes of our 50 years of research by now. And in terms of our data collections, we really invest in that. That's really where government agencies are good at. Long-term data collections. Not a lot of other entities can really do that. So that's what we focus on. And that means monitoring the most important segment of the population, females with cubs. That means investing a lot of effort into live captures for research and radio telemetry monitoring observations and mortalities within the entire ecosystem. So those data collections, you can imagine after 50 years, they're pretty substantial. We collect samples, the tissue and blood and hair samples from all these animals that we use for research captures. And so we're building up tremendous databases that have been useful in a large number of projects. Now, an early finding from this work was that there was a high adult female mortality. And so when you have high and with large vertebrate populations, adult female survival is the critical factor for population viability. And so it was, from some of the early work, it was determined that the mortality risk was just too high for this population to recover. So something had to be done on the ground to change that. And that really brought up the discussion of, how do you actually, now that we have at least the first signs back in the 70s and early 80s, now that we have that first signs, how do we implement that into an effective conservation strategy? And how do we reverse the trend? So in a lot of projects, in a lot of situations, this is kind of a touchy point, I think. This is when species could actually fade away, or populations could fade away if the right decisions are not made to translate that science into some actions, conservation actions that are actually effective. So that's what managers and researchers were facing at the time. And this is especially applicable to a species that's long-lived, slow life history. So any action you do next year is not going to make a difference. You really have to think long-term. It's a multi-jurisdictional ecosystem with lots of agencies managing or having responsibility for the species, either land managers or wildlife managers. And so a lot of complexities turn into this at this point. And so the real critical issue at that point in the late 70s, early 80s was, how do we translate science into good policies? And so that's where this notion was born, where the interagency Grizzly Bear study team would be reporting to a newly established committee, the Interagency Grizzly Bear Committee, established in 1983. And this committee oversees actually all the conservation actions in the lower 48s. But the idea was that we can inform that committee, and people serving on that committee are in leadership positions with their respective agencies. So we're talking regional directors of the Park Service, regional directors of the Forest Service, state directors of the state wildlife agencies, people that have influence and that can say, this is what we're going to do, and this is how it's actually going to change on the ground. And so that was the idea behind it. And I think it has proven to be very effective, as we will see here in a moment. So these are the people that can make decisions that really translate to changes on the ground. So I'm just an advisor to that committee. I don't have a vote on that committee as a science person, of course. But these are people that get together twice a year and have been for the last 4 years. They celebrated their 40th anniversary last year. So that being part of a larger recovery program for grizzly bears in the lower 48s, that really consists of 5 basic elements. It started really with the focus on reducing adult female mortality, as we talked about. That was a critical component, not just for Yellowstone, but also for some of the other ecosystems that I'll show you here in a moment. Developing habitat standards to promote that survival of adult females, and that meant making some really difficult decisions for land managers to restrict motorized access, for example, to retire livestock grazing allotments, to limit the number and size of developed sites on public lands and that sort of thing. Those were some pretty tough decisions at the time. It also meant being very responsive to conflicts. Wherever you have grizzly bears and people in the same landscape, there's going to be conflicts. And so you need to have agencies that are responsive to that. And that's primarily been the responsibility of the state agencies. And they've done a really good job in basically sending the message to the public. If you have a problem, we're going to be there to help out as much as we can. And they've done that. Information education is a big component that has improved in recent years, even more so. I think there's more and more emphasis on that to try to prevent and reduce the number of conflicts to begin with. And of course, the emphasis on research and monitoring is still there. And I think everyone on the Interagency Grizzly Bear Committee and its subcommittees recognize the value of that. So as part of the entire program in Lower 48, there's 6 recovery zones. Only 4 actually have occupied range, actually have grizzly bears. The Bitterroots and the North Cascades do not. There's efforts on the way in the North Cascades. Recently, an environmental impact statement was finalized with a preferred alternative that would potentially lead to a reintroduction for that population. Some of those similar work is going on with the Bitterroots, but the environmental impact statement has a recent one that was initiated has not been finalized yet. In Yellowstone, as you'll see, we'll have close to 1,000 bears in the Northern Continental Divide, a little over 1,100. Cabinet Yaak has about 60 to 65 bears, and the Selkirk in the combined Canadian and U.S. part is between 80 and 90 bears. So 2 very healthy populations and 2 smaller populations that are slowly recovering and doing relatively okay, and then 2 unoccupied. So there was a broad recognition that the IGBC has facilitated bringing grizzly bear populations back from the brink, so to speak. And one important thing I've highlighted here is the public acceptance of the practices that these agencies implemented. In the beginning, that public acceptance wasn't necessarily there. You know, it's not a popular thing to close down forest roads or access. It's not a popular thing to limit livestock grazing and that sort of thing. So that took a period of time to really work through that. But in the end, that was very effective. And that led to, we're going back to Yellowstone now, that led to a really substantive recovery of the population. So this is based on some new monitoring and analysis techniques we've implemented in the last couple of years, based on some of you may have heard of integrated population models. This is literally where all our data streams are combined into a holistic, unified model to estimate population size, to estimate all kinds of demographic parameters, survival, reproduction, population growth. And as you can see, that trajectory looks pretty good. We still had, as you can see, at the very beginning, there's a little dip down that is still probably a reflection of the declining population into the early 80s. But then those conservation actions started to take some effect. And by the mid to late 80s, we started to see some growth in the population. Then really pretty robust growth during the 1990s. That was really the time period where the population recovery really kicked into gear. 5.8% growth for a grizzly bear population is really good. And then we started seeing that slowing down. Starting in the early 2000s, we started seeing the population growth slowing down, and that has continued in more recent decade. And we'll talk a little bit in a moment about what some of the reasons are behind that. Like I mentioned, we have our latest estimate for 2022 is 965 bears. That's estimate for 2023 is not official yet, but it'll be close to about 1,000 bears. So certainly a healthy number considering where we came from. Of course, with population growth, we have range expansion, and we've seen almost tripling of range expansion since that period in the late 70s and 80s. And I'll point out a couple of boundaries here. The black lines are, of course, the national park units. The yellow line is the Fish and Wildlife Service defined recovery zone. That is 98% public land, so that is a well-protected core area. And then the blue line is what we as the Interagency Grizzly Study Team have defined as the demographic monitoring area. And that's basically where the suitable habitat for the species is, and the area that we are capable of monitoring. That's, you can only monitor, and it's a large area, 50,000 square kilometers, but there's only so much area you can truly monitor. So we decided back in 2012 that we're going to have to limit that to the area where the defined suitable habitat is. Just for reference, this point here is closer to Denver than it is to Bozeman. On the South Pass here in the Wind River Range. So it kind of puts it in perspective how large of an area we're really talking about. Of course, population growth, population expansion, what we've also seen is increase in bear density in portions of the ecosystem. So this is in 1990, the darker blue colors are lower densities, but anywhere you see a cell where there is a color, that means there are bears there, and blue is lower density, yellowish, lighter colors are higher density. And when we look at that over a couple of decades like this, you see some pretty distinct changes, increasing density in some of the core areas like Yellowstone National Park, around Grand Teton National Park, but also some of the wilderness areas where we see pretty high densities of bears. Now you might wonder, why do I mention that? Because we are seeing that bear density as kind of an intrinsic factor in the population starting to play a more prominent role. It's starting to affect, and has been since the early 2000s, starting to affect some demographic parameters. And we know, for example, that little cubs like this, especially early in the season, are vulnerable to getting killed by other bears, typically males, not always. And so this is a perfect photo that shows that type of potential. And indeed, in our data we published in 2016, when we looked at our density index that we developed with long-term data, and we looked at cub survival. In areas where density index was relatively low, we saw a little bit of decline in cub survival starting in early 2000s, but not much. But when you go to areas with higher bear densities, that survival effect was stronger, and it's strongest in the areas with the highest bear densities. So what that means is that in areas with higher bear densities, cub survival is lower, and that can have a pretty profound effect on population growth. And that is the reason, together with a little bit lower yearling survival as well, and some evidence of density-related reproductive suppression, that is the reason that population growth started slowing down. To me, as a biologist, that means that we've kind of reached the capacity of this system to support, in portions of the ecosystem, especially in the core, to support this population. So we're really reaching this level of what I would call biological recovery. Interestingly, in recent years, we've done some additional research looking at density effects, and we also found an effect on lean body mass, especially of younger growing age females. So this is females up to 7 years old when they're in their physical growth stage. And what we found was that in areas with higher bear densities, these females that are less than 7 years old have a lower lean body mass than in areas with lower densities. And that probably reflects the fact that they're having a hard time competing with all these other bears that are out there. The reason that we looked at lean body mass, by the way, is that because bears gain so much fat over time, total body mass is not a good metric. Depending on when you measure it in what season, you get a very different number. So lean body mass kind of takes that confounding factor out of it. We saw a similar effect with males, just no effect of age. That was more of a general relationship. So there's evidence that in areas with higher densities, there's more competition. It's harder for animals to reach that same level of body mass. Now, that's not to be interpreted as saying something about the health of the population. If you look at the individual health of the animals that we capture, and we do that by looking at seasonal body fat gain, because that's a good indicator of how many calories these animals are able to acquire on the landscape and gain through the active season so that they're prepared for hibernation. If we look at that and we compare 2 decades, 2000 to 2009 versus 2010, 2020, decades where we have a vastly different landscape. And in the 2000s, we lost a lot of whitebuck pine. We lost cutthroat trout out of the tributary streams to Yellowstone Lake. Elk herds have changed. Lots of things have changed in this ecosystem. And so we were curious, is that reflected in how bears are gaining body fat for those 2 decades? And we found that it didn't. There was no difference between these 2 decades. So despite a vastly different calorie landscape, it doesn't seem to affect how bears are obtaining the calories. Now, the black dashed line is at 20% body fat. That is important for females because that's basically a threshold for reproduction. If female bears that are pregnant go into a den with at least 20% body fat, that typically means they can produce cubs in the following January, February. If they're below that threshold, they typically don't. We saw a similar relationship for males, so the news is good here, and that it shows that these are pretty resilient animals. You know, we don't call them opportunistic omnivores for no reason. You know, that they really are amazing at finding calories on the landscape. With expanding populations, we are also in a very different situation with the potential for genetic connectivity with other populations. And so here the hatched areas are the latest estimates of occupied range for the 4 occupied ecosystems. So that includes the Northern Continental Divide and Cabernet Jack and Selkirk ecosystems. And the reddish transparent areas are basically areas where there have been verified observations of grizzly bears, and those are assigned to hydrological unit codes, so they're reflecting a little bit larger area. But that gives us an indication of where bears have shown up, not actually occupied range yet, but those are places where bears have been verified to have shown up in the past. And now recently, you probably heard about the bear in the Bighorn Mountains. There was one removed recently that was in the southern portion of the Bighorn Mountains. So that's quite a jump from presumably from the Greater Yellowstone ecosystem. We don't know that yet. We need to do the genetics on it. But the good news is that we are probably closer now to actual genetic connectivity than we have in decades, if not longer. You know, the Greater Yellowstone population is still genetically isolated from other populations. And when we looked at the potential paths that bears might take from the Northern Continental Divide to the Greater Yellowstone ecosystem, those darker lines, the purple lines, show areas that are the most likely pathways for bears to take. And as you can see, you know, there are some barriers in between. You know, you got the interstates, you got quite a bit of agricultural lands and occupied lands. You know, Bozeman is kind of in the mix of all that too. And it's these little stepping stones of federal lands, mostly Forest Service lands, that will be very important for that if natural genetic connectivity is ever to happen. Now, some of you may be aware, Montana Fish Wildlife Parks is starting a program of agency-assisted genetic augmentation that will start this year, and that will, by literally translocating some bears from other ecosystems, most likely the Northern Continental Divide ecosystem, into the Greater Yellowstone ecosystem to provide some human-assisted genetic connectivity. Now, I should point out that we're not in dire straits with the genetic situation in the Yellowstone population. It's lower than the other populations, the genetic diversity is, but it's not at a level where it raises a huge concern for the immediate future. You know, it's really a much longer term issue. And for the long term, you know, we are reaching genetically effective population sizes close to 500 for the population. So I think we're sitting pretty good. But there's been a lot of court attention to this issue, and so that's why we addressed it. With only 60 miles between the 2 outer edges of occupied range, we're actually basically within striking distance of a male dispersal. And so it's certainly possible that it can happen. It maybe already has happened. We just haven't documented it yet. It takes a couple of years usually to get genetic results back from our samples. Now, of course, conservation success for an animal like grizzly bears also means some associated challenges. And that challenge is, of course, with increasing incidents of conflict, whether it's in campgrounds, getting into campers, outfitter camps, residences with garbage or depredation issues. We have seen an increase in those numbers. Now, interestingly, in the recovery zone, which again is 98% public land, there's been pretty good control of conflicts. You know, you have a lot of control over, or land managers have a lot of control over how things are done and managed in those public lands, and we have not seen any trend in that. But as soon as you get into the broader area of the demographic monitoring area, and especially beyond, you see there's some pretty substantial increase in conflicts over time. And, when we have, something like 400 conflicts every year, that's a tremendous amount of effort required to deal with all that. So that is a real challenge. It also tends to erode support for the species if people feel like they're suffering a lot of the consequences of this conservation success. The actual landowners and ranchers that have to suffer those consequences directly. And of course, with more bears in more places, including more places where there's more human activity, we're going to see more of this, more mortalities. I'm not showing this for shock value, but it is a reminder that we're all part of this ecosystem. This is actually an ecosystem that is not as wild as we think, or we'd like to think. There is a lot of human influence. There is recreation all over the place. I don't know what backcountry means anymore, because when you go into backcountry, you see people everywhere. So there is a lot of human activity in this place, and we're all, I think we have to recognize we're all part of that, and we're all part of the risks that we pose to grizzly bears. That's why this notion of source-sink dynamics, I think, is really relevant at this point. And so what we're looking at here is a map of adult female survival. It was produced back by Chuck Swartz, my predecessor, and his colleagues in 2010. And the red areas show areas of high female survival. This is a spatially explicit model. And blue areas show areas with lower female survival. And you can use that to actually kind of map out where potential sink and source areas are. Because if you also know what your reproduction is, and recruitment into the population, you can actually predict at what survival level of females you would need to achieve to have positive population growth versus what would happen if you have negative population growth. And so for that analysis, that threshold was right around 0.91 female survival, so 91% annual survival for females. If you're above that, you can typically consider those areas as source areas for the population. So those are the yellowish or the beige areas, and then the blue areas reflect areas that really kind of act as sinks, where without supplementing bears from the source areas, those sink areas would eventually just not able to sustain populations themselves. So that means that, if you look at, like on the eastern side, on the northeastern side, and around Cody, for example, there's only so much area where we can expect these populations to expand and be able to retain that occupied habitat. There's just so much human influence in some of those areas that we cannot reasonably expect bears to make a decent living there without a high risk of mortality. And what you clearly see is a very distinct imprint, of course, of road networks, right? And the road networks, it's not so much like in the previous slide where there is direct mortality from vehicle collisions that plays a role, but it's a relatively minor source of mortality. It's just access into bear habitat that really drives this. Access into bear habitat means more conflicts, more removals, more self-defense skills, more kind of accidental deaths that we tend to see. And keep in mind, 85% of all mortalities in this ecosystem are human caused. So areas where there's greater access, where there's more humans, simply have a higher risk of mortality. So with that in mind, this is really a time where people are asking the question, how many bears do we need in this ecosystem for a healthy population, for genetic health? And how many bears is ideal to also find that balance between tolerance, public tolerance of bears, for those people that actually have to deal with the consequences of bears on the ground. And we've kind of reached that point right now. And so there are revisions being made right now to what is called the conservation strategy, which is if and when this population is delisted, that spells out exactly how this population is to be managed into the future. And one of the revisions that is being made right now is to strive for population size between 800 and 950 bears or higher, and that being a reasonable balance between all these different goals for the population. And so that is currently being revised in the conservation strategy. The Yellowstone Ecosystem Subcommittee will look at that next week, and then it will go on to potentially to vote for the Interagency Grizzly Bear Committee. So then to wrap up, I want to talk a little bit about what have been some of the elements of this success. This I think everyone in the room here would agree that this is a remarkable conservation success story, considering the nature of this animal. It's not necessarily the easiest animal for especially for landowners to deal with. They can be potentially dangerous, and I think it speaks a lot to us as a nation that we were willing to recover a species like this and put so much effort into it. So there are basically 5 elements of success, and I modified this from something that the former recovery coordinator for the Fish and Wildlife Service developed, Chris Servine. There's basically 5 elements to a successful conservation program. And I think the point here is to, following the theme of and the title of the presentation is, that science alone cannot do this, right? You need a lot more than science and biological data to develop a successful program. That is really only the start of it. What we also had was state, federal, tribal organizations working together very well and coordinating their efforts to protect habitat for grizzly bears, to protect bears themselves, and really coordinate that in a way that guarantees long-term success of this program. We also had a lot of public support. I think that stems from the fact that we're dealing with a very charismatic species that is really a symbol of the American West. So people love bears, of course. 399 has their own Facebook page, and etc. So there's been a lot of public involvement, and it's been great. There's also been a lot of public involvement in the meetings from the Interagency Grizzly Bear Committee and its subcommittee. I think that's been really critical for support as well. There's not only involvement, but opportunities for the public to comment at every meeting. So managers hear directly from various stakeholders what they think about what about their decisions. And that, I think, has been really critical to this success. Political support has been important too, of course, that always is, and especially early on in the 80s, 70s and 80s, I think this was really critical. There were not a lot of political leaders at the local, regional, or even national level that were willing to see this population blink out on their watch, and that's because we're dealing with a very iconic species in an iconic ecosystem. And so that's, I think, has been really, really constructive as well. And then finally, I think the fact that we have a large protected area, a large core to this ecosystem with the national park and some wilderness areas that provided that refugium for bears to survive. Had we not had that, I don't know that we would still have grizzly bears in a place like this. But those large protected areas that have been there for a long time, with the establishment of Yellowstone National Park as the first national park in the world, that was key to this success as well. As well as, of course, the Endangered Species Act. That law has been very instrumental in really making an actionable recovery plan. But before we pat ourselves on the back too much, let's give a little bit of credit to the bears as well, because they are incredibly resilient, even in a landscape like this where we have lots of human activities. They can be potentially dangerous, but they typically avoid people at all costs. So despite the potential for really bad situations, we should credit bears for not getting us into bad situations. And I think this quote from Robert Porter Allen was well known for his work on whooping cranes and other bird species. I think this quote just captures it perfectly. So let's go back to this diagram and focus a little more on the role of science. And when we're talking about the role of science, we're really talking about how science and biological data has informed decisions by management agencies, and has also framed the public debate around grizzly bear conservation. And of course, for that, you need good science communication. Now, I kind of look at science communication for scientists as in kind of three levels. We do a lot of communication with our peers, of course, but also with managers and public stakeholders. So we tend to do a pretty good job at publishing our findings and the results. At least your paper is right there, recent paper. We do a good job at that, and that is important, of course. We need to establish the validity of the data, what the implications are, but that alone does not get at the impact of the science, right? Just publishing doesn't create an impact. The impact really happens, in my experience, in places like this. This is to show the Yellowstone Ecosystem Subcommittee of the Interagency Grizzly Bear Committee. These are the people that do make the decisions that change things on the ground. And so by frequently interacting, us as scientists interacting with members of that committee, I love this art because it's a pretty good reflection of sometimes how these committee meetings go. But by informing the committees of our science, it has really changed. It really allowed them to make solid decisions, and it's been very gratifying as a scientist to see that what we actually present as our science to these committees, that they are almost immediately implemented. And we've seen that recently with our implementation of the integrated population models, for example. The changes that were required in the conservation strategy were all because we made a change, and they immediately responded to that. And that is really very gratifying to see. Of course, it's also important, especially like for scientists as myself, government scientists, to also report and communicate our science to the public. And that means popular science articles, books, chapters, public meetings and public presentations, media interactions. We do quite a bit of that, and even some social media stuff. I'm glad we have people in our office that does that, because I would not be good at that. But it's all important that we do that. So it's really, it's all about communication, right? And this is where I think sometimes we lack in our curricula. I don't know if there is a requirement, for example, there is for science communication, and that's great. But that's probably a fairly recent implementation. And there's a lot of ecology or conservation biology and wildlife science programs that don't do this yet. But I think science communication is really important. I never got that training. I got it. I had to learn, and I was fortunate to have people in my office that were really helpful and good at that. But that's something that I think knowing how to communicate science to different audiences, especially, it's one thing we do, like I said, we do a good job of communicating that to our fellow scientists. We don't always do a very good job of communicating that to managers. And that's really where the rubber hits the road, in my opinion. When we're talking about science communication, there's also this kind of tricky situation of, when is it science communication and when are we kind of verging into advocacy? And that's, there's kind of an ongoing debate. In conservation biology and wildlife science, there's kind of value-laden disciplines, right? So some people say we need to be advocates for the species, and we need to be advocates for this and that. But I think that's really tricky, and we have to be really very careful around it. And that's why I really appreciate this quote from Robert Lackey from a paper in Conservation Biology in 2007, where he makes the point, scientists are indeed uniquely qualified to participate in public policy deliberations, but they should not advocate for particular policy positions. And believe it or not, that does happen, maybe more than we're willing to admit, and it can kind of sneak in sometimes. So it's something I think we really need to be aware of. From a more recent paper, a peer et al., which has a good, some authors with a lot of seasoned authors with experience. I think they also to make a similar and very, very valid point. And especially this notion of the credibility of science. You know, for example, if I came out and said I'm for or against delisting this grizzly bear population, just imagine that anyone that opposes that view would immediately discredit anything I've ever done, right? Because they would not agree with me, and they would basically, I have lost all my credibility. And as a scientist, credibility is the only thing we got, right? So I treasure that, and I really try to be very conscientious and conscious about that all the time. And like I said, it can, this kind of advocacy, you know, agenda-driven science can kind of sneak in sometimes. So that's why Peer et al. Made some 4 really good recommendations, I think, of we collectively as scientists, how we can improve on that. And that starts with ethics courses, science communication course. Is there an ethics course in ecology or wildlife science here? I actually had one at the University of Tennessee. I did some lectures in a course like that. And it was actually really, really instructive, I think, for everyone, including the instructor. So another thing that we can work on is develop tools and procedures for recognizing and responding agenda-driven science. I see this primarily as a role for journal editors and reviewers, you know, that really need to look for, you know, is there an agenda here with the science that we're evaluating? And for authors, I think it's important to disclose any potential conflicts of interest. That is fortunately happening. A lot of journals are requiring that now, but I think we should actually just volunteer that, you know, say, hey, we have no conflict of interest, or this is something, you know, I've done some consulting for such and such. That could be a potential conflict of interest. Let's be transparent about that. And in the age of social media, you know, the combating the spread of disinformation or misinformation is really challenging, of course, but I think it's upon us as scientists to be proactive in that, and especially for our professional societies to play a proactive role in that as well. I think there's a lot that societies can do, and I see more of that happening. I see societies, professional societies, especially in the medical field, but I see it also in the wildlife field, responding to that. And then finally, this notion of fostering a diverse scientific community, I think has a lot of validity. And I speak from that kind of from my personal experience with the interagency grizzly bear study team. If you look at the members of our study team, and I want to acknowledge all of those members here, they come from very different scientific backgrounds. They come from agencies with very different scientific or management missions. And when you bring all those different opinions and different approaches together, you end up with a really much better product than any scientist singly by him or herself could do. You know, so that and you should see some of the discussions and debates that we have within our study team. They're sometimes like, whoa, it's really, really hefty discussions, but we always reach a consensus in the end. And so by people coming from very different perspectives and still getting to a final reliable product that has given us the opportunity to after 50 years, to keep the science salient and meaningful to a broad range of stakeholders and credible. And I think that is always a huge challenge. And having all these people behind that makes a big difference. In the end, you know, it's really about us being gatekeepers of our own integrity. So with that, I'm happy to answer a few questions or comments or whatever you have.
It's really interesting, particularly putting in that overall perspective and like you brought up, the uniqueness of this species in terms of making those management decisions. Obviously, an interesting contrast right now in the greater yellow ecosystem is the bison. And I wonder if you have any thoughts on that, because you have such a different, an herbivore, different numbers, all these kind of different interactions with the landscape.
Well, I mean, there's a lot of interagency effort on bison as well. It's, they don't quite cover the same extent of landscape, of course. And I'm not intimately familiar with all the bison management, but there is quite a consortium of groups and agencies working together on that as well. So I think there's actually quite a few similarities between bison management and grizzly bear management in that sense. It's equally controversial, or maybe more so.
More, yeah, no, I think it's more so, but that's because of the nature of the species, right? And I mean, grizzly bears, it's just, you don't want to be killed by them, or you don't want your, but here where people are talking about putting bison over a broader landscape, and that brings up so many more issues.
Yeah. But I think it's certainly has benefited as well from kind of an interagency approach on various aspects of it.
What are the current hindrances or roadblocks to delisting and or transition to state level management of the grizzly bear?
Yeah, that's a really good question. I guess ultimately it's really the decision rests with the Fish and Wildlife Service. They would have to look at the past court cases, and develop a new rule to delist, a proposal to delist, and consider some of the new management recommendations with regard to population objectives and all that. So that is occurring presumably as we speak. I don't know when the Fish and Wildlife Service will have a decision made, but I wouldn't be surprised if that's occurred sometime this summer, maybe. Because one thing I didn't mention is both states of Montana and Wyoming have petitioned the Fish and Wildlife Service to delist the Northern Continental Divide population by Montana, and then the Yellowstone population petition was from the state of Wyoming. And that occurred, I think it was March 2023, and that triggers a 12-month finding from the Fish and Wildlife Service to respond to those petitions. Or no, actually, last March in 2023 is when the initial petitions were deemed valid in terms of that they needed to be evaluated, and that triggers a 12-month response time from the Fish and Wildlife Service, and we should be getting pretty close to that. So there's a lot of administrative aspects to that, but basically the conservation strategy has been updated and has gone out for public review, and comments have been received. Those have been incorporated into the conservation strategy, and those will be presented next week at the Yellowstone Ecosystem Subcommittee here in Bozeman, by the way. So if you're interested in that, it will be, I think, at the Marriott Hotel next week.
We have just one more question and then we'll let everybody go.
This issue of genetic connectivity, should we be casual about it? Is it already happening, or does it require human intervention? In which case, who?
Yeah, so I wouldn't describe it as we should be casual about it. I think it's certainly something that is a desirable condition. If there is genetic connectivity from another ecosystem, that is a desirable condition, no doubt about it. I don't think we need to freak out about the current situation. We have decades before we would see any effect of given the current levels of genetic diversity. So it's not if you ask me what is the biggest concern for this population, it's not genetics, it's humans, right? It's development, it's recreation, climate change. Those are the things that we should be concerned about more so than genetic connectivity at this point. And fortunately, genetic connectivity is relatively, it's not pretty for everyone, but if we assist with that effort, as Fish and Wildlife Parks is planning to do, we can address that relatively easily. it's not among the purists, I guess it's not what some people want, maybe, you know, people want a natural connectivity, but if the goal is to increase genetic diversity, it doesn't matter if it's a human that dumps a bear in there or if where the bear does that itself. That's different philosophies, but so that's really where we're at with it. And that human assisted, agency assisted augmentation is likely to happen in the coming years.
Frank, thanks for a wonderful talk.